LSG is leader in lighting and electrical test instruments. Hello everyone, this is Daisy. Let me introduce to you the installation and use of the LSG-3000 LM79 Moving Detector Goniophotometer. The following is the video catalog. 1. System installation. 2. System calibration. 3. Measurement. 4. System maintenance. Please check the packing list when you receive the shipment. There are 9 wooden cases in total. Some parts of Goniophotometer are very heavy. More attention should be paid in the process of handling and installation. The largest wooden case contains LSG-3000 base, mirror frame, near field arm. The wooden case with dimensions of 147 cm 38 cm 114 cm contains light arm, C-axis. The wooden case with dimensions of 51 cm 35 cm 27 cm contains LS series digital power meter. LSG has 3 kinds of power meters, LS2008R, LS2010, and LS2012. The wooden case with dimensions of 55 cm 55 cm 29 cm contains DC power supply. The wooden case with dimensions of 58 cm 57 cm 33 cm contains AC power source. LSG has 3 kinds of AC power sources: LSP series high precision AC power source, LSP VARS series AC power supply, LSPS series AC power supply. The wooden case with dimensions of 122 cm, 90 cm, 33 cm, 144 cm contains the mirror. The wooden case with dimensions of 181 cm 78 cm 79 cm contains the cabinet. The wires here are used to connect the cabinet with the goniophotometer. The wooden case with dimensions of 76 cm 57 cm 199 cm contains FAR detector frame. The wooden case with dimensions of 117 cm 93 cm 60 cm contains other accessories, including FAR detector and FAR detector related accessories. There are 2 detector tubes, one with mirror and the other without mirror. Cross fixture, E27 fixture, candela standard lamp and extension rod, spot laser, temperature hygrometer, spot laser fixture, toolbox, with a special wrench for mirror screws, and various screws. 1 encryption dog is needed to run the LSG-3000 software. It's in the standard lamp box. Open all cases and remove the equipment and accessories. The wires left by the equipment should be covered with insulating tape. Do not remove the insulating tape until the corresponding cable is installed. The software is needed in the process of hardware installation and adjustment. Copy the files to your computer. Double-click the installation file to install the LSG-3000 software successfully. 2 drivers also need to be installed. Double-click to install the drivers. Plug the encryption dog to the USB port. Put the power meter, DC power supply and AC power supply into the cabinet from top to bottom. This temperature hygrometer needs to be installed in the darkroom to monitor the temperature and humidity inside the darkroom. Connect the RS-232 communication cable and power cord to the temperature hygrometer. Connect the 4-core test line, RS-232 communication cable and power cord to the back of the power meter as shown. Connect the DC output wires, RS-232 communication cable and power cord to the back of DC power supply as shown. Connect the AC output wires, RS-232 communication cable and power cord to the back of AC power supply. Here is the communication box for the whole system. All the devices that need to communicate are connected to the communication box, and then connect to the computer through this USB cable. Remove this circular baffle of the darkroom. Install it back after the system installation and adjustment is finished. Place the LSG-3000 base at the correct position according to the darkroom drawing. This side faces the FAR detector. The wiring panel is on the back of the base. It is important to connect grounding line here for the LSG-3000 system. Find the correct cables and connect the base with the cabinet. Install the spot laser fixture to the LSG-3000 base. Install the spot laser to the fixture, and turn on the laser. The red laser points to the wall at the far end of the darkroom. Attach a piece of white paper with removable tape where the laser light hits the wall. Connect the power cords of the cabinet and the LSG-3000 base to the 220V 50 Hz power. And turn on the cabinet and the LSG-3000. Open the LSG-3000 software on the computer. Click Test System Configuration. Choose the right model of your goniophotometer. And click Auto Find Port. Then do the same for the power meter, DC power supply and AC power supply. There may be error message when communicate with the goniophotometer. It's okay because the assembly has not been completed. If other devices fail to communicate, please confirm whether the communication box driver is installed successfully, whether the RS-232 communication cable of the corresponding device is connected, and whether the corresponding device is switched on. Enter Test Rotary Actuator Control Panel. Choose Far Field, click to go. Fill in 0, 90, 180 and 270 in turn, and then rotate to the specified angle. At the same time, another colleague takes a pen and draws a circle on the paper following the trajectory of the laser. After the circle is drawn, adjust the 4 hexagon socket screws around the spot laser to adjust the spot laser to the center of the circle. Then repeat until the laser traces a point instead of a circle. Turn off the LSG-3000. Adjust the LSG-3000 position again, and also the pitch, adjusted by 4 large adjustable screws at the bottom of the base. Make sure the laser line is in the center of partition holes. All the 4 large screws must be firmly on the ground at the end of the adjustment. Place the FAR detector frame at correct position according to the darkroom drawing. Install the FAR detector frame mirror tool. Adjust the position of the frame and pitch, adjusted by the 4 adjustable screws at the bottom of the frame, so that the laser from the LSG-3000 base is irradiated to the center of the small mirror and the reflected laser coincides with the original laser completely. And the 4 adjustable screws must all be firmly on the ground at the end of the adjustment. After the LSG-3000 base and the FAR detector frame positions are fixed, it will never need to be moved again. Otherwise the test data will be deviated. Connect the cables of the FAR detector frame to the LSG-3000. Another 2 wires need to be connected to the internal servo amplifier. It needs to enter through the gap between the bottom of the LSG-3000 and the ground, and connect to the corresponding position through the hole here. Note that the labels on the lines and servo amplifiers should correspond to each other and not be misconnected. Remove the spot laser fixture and the laser. Ready to install the light arm. Remove the screws for fixing the dust-proof cloth on both sides. Remove all the small screws around the cover plate. Please note that the up and down switch is wired internally when you take it off. Remove the cover plate. Please remember the position of the 6 wires, and then pull out the 6 wires. After the light arm is installed, the cover plate needs to be installed back. There are 2 cables in the center of the LSG-3000 base. The light arm is heavy. You can use a forklift to lift it in the direction as shown in the picture. Pass the two cables through the hole in the middle of the light arm as shown in the picture. Two aviation plugs are from the left side and the other one is from the right side. Aim the middle hole of the light arm at the cylindrical convex part. Remove the drag chain of the cable if necessary. Then fix the light arm tightly with 6 hexagon socket screws here. Connect the two aviation plugs with the corresponding wires in the light arm. Connect the other wire to the motor according to the labels. Plug the 6 wires of the up and down switch back to the original positions. Install the cover back. Fix the cover plate and dust-proof cloth again with the corresponding screw. The two ends of the G-axis are different. Only one end is with wires. The end without wiring needs to install the mirror frame. If it is not convenient to install, you can start the machine. Rotate the G-axis to a convenient location in the software and then shut it down for installation. As shown in the figure, the mirror frame can be placed on the forklift and lifted to the same height as the LSG-3000. 10 hexagon screws are needed to fix the mirror frame. Then rotate the other end of the G-axis to a convenient position to install the near detector. In the same way, the near field arm is placed on the forklift and lifted to the same height as the LSG-3000. Pass the wires of the near detector through the hole. 10 hexagon screws are needed to fix the mirror frame. Then connect the wires one by one according to the labels. Then install the mirror. Please be careful and don't break the mirror. Rotate the far field G-axis to 0. The mirror frame is rotated to the bottom. There are 3 sets of bolts and nuts on the back of the mirror. Unscrew the 3 nuts and gaskets on the outside. Align 3 bolts with 3 holes in the mirror frame. Then install the 3 nuts and gaskets back and fix the mirror on the frame. Turn on the LSG-3000 Goniophotometer. Rotate the G-axis to 90 or 270 degree position. Install the spot laser to the light arm and turn on the laser. Tighten the screw with handle to prevent the laser from falling out. Adjust C-axis coaxial in the same way as G-axis coaxial adjustment. Attach a piece of white paper with removable tape where the laser light hits the floor. Click to go for C-axis. Fill in 0, 90, 180 and 270 in turn, and then rotate to the specified angle. At the same time, another colleague takes a pen and draws a circle on the paper following the trajectory of the laser. After the circle is drawn, adjust the 4 hexagon socket screws around the spot laser to adjust the spot laser to the center of the circle. Then repeat until the laser traces a point instead of a circle. Click Detector Axis Go to 0 on Software Rotary Actuator Control Panel. The G-axis will go to 0 degree automatically. And then the far detector axis goes to 0 degree too. Install the far detector after both the G-axis and the far detector axis stop rotating. Pass the 2 aviation plugs through the hole in the middle of the detector holder. Install the detector on the frame in this direction as shown. Plug the 2 aviation plugs to the corresponding sockets of the detector. There are 4 screws that used to lock the detector. Don't lock it too tight for now. There is another mirror tool that used to install on the far detector. Install it to the far detector as shown. Then the laser goes to the direction of the far detector mirror. Now, we need to adjust the 3 screws on the back of the mirror, and also the direction of the far detector, so that the laser returns to its original point after repeated reflection by the 2 mirrors. This step requires fine-tuning and a lot of patience. After the adjustment, all screws to fix the mirror and far detector should be locked and never loosened again. Otherwise the test data will be deviated. Remove the mirror tool from the far detector and restore the far detector to its original appearance. Take out the cross laser and load the battery. There is a lock switch on the side which can be kept in the unlocked position and no need to change. There are two switches on the top of the cross laser for vertical laser and horizontal laser. Install the cross laser on the fixture and fix the cross laser fixture onto the wall according to drawing. According to the drawing, there is also a marker on the opposite wall. Turn on the cross laser, and rotate the cross laser so that the laser points to the marker. Then the horizontal laser overlaps the G-axis and the vertical laser overlaps the C-axis. And the center line of the cross laser is perpendicular to the G-axis. If necessary, the position of the cross laser and the position of the marker can be fine-tuned to meet the above three elements. The hardware installation and adjustment are finished. Install the circular baffle back. Put the black cover on the mirror and cover the detectors. Clean the darkroom and wipe the machine. Then remove the covers. We need to calibrate the far detector, near detector, and the spectroradiometer before measurement. Rotate the G-axis to 45 degrees. Turn on the cross laser and aim the laser at the opposite marker. Take out the candela standard lamp and extension rod. Fix the standard lamp on the extension rod. Fix it tightly to prevent the standard lamp from falling out. Pull out the bolt, and insert the extension rod in the light arm. Tighten the screw to secure the standard lamp. There is a small mirror on the standard lamp. By adjusting the height, direction, and pitch of the standard lamp, the cross laser should go to the center of the mirror. The reflected horizontal and vertical lasers coincide with the original horizontal and vertical lasers. This step also requires fine-tuning and a lot of patience. After the adjustment, the cross laser can be turned off. Then remove the mirror from the standard lamp carefully. Find the certificate of the standard lamp. There are candela, color temperature, voltage, and current values. LSG standard lamps are all constant current DC lamps. Switch the AC-DC switch to DC. Click the DC button to enter the DC power control interface. Input the voltage and current of the standard lamp, and then click Output. Now the DC power supply should output the same constant current value as the value on the certificate. Standard lamp needs to be warmed up for at least 5 minutes to reach a steady state before calibration. As for the G-axis angle, it is 0 degree when the mirror is directly below. Stand in front of the LSG-3000 Goniophotometer. When the G-axis rotates clockwise, the angle changes to 0 degree, 90 degree, 180 degree, minus 180 degree, 270 degree, minus 90 degree, and 0 degree. Take the cross laser installed in the direction of G-axis 270 degree as an example. Rotates far field G-axis to 270 degree. The light of the standard lamp goes through the hole to the mirror, and then to the far detector. Now we can go on to calibrate the far detector. Turn off other light in the darkroom. Close the door. System configuration. Click Candela Calibrate for far detector. Enter the candela value of the standard lamp, and click OK. The calibration distance automatically appears here. Rotate the near field G-axis to 270 degree. The light of the standard lamp goes through the hole to the near detector. Now we can go on to calibrate the near detector. System configuration. Click Candela Calibrate for near detector. Enter the candela value of the standard lamp, and click OK. The calibration distance automatically appears here. Angle rotary control panel. Rotate the spectroradiometer G-axis to 270 degree. The light of the standard lamp goes through the hole to the sensor of the spectroradiometer. Now we can go on to calibrate the spectroradiometer. Click Spectrum Calibrate, enter the color temperature value of the standard lamp, and click Calibration. Click Save and Exit after successful calibration. Re-enter the DC control panel. Click Off to turn off the standard lamp. The standard lamp is very hot after using. Put the standard lamp back to the box after cooling. It is suggested to do the candela calibration. Flux calibration is another calibration option reserved for the software. There is no need to do flux calibration. If need to do flux calibration, please contact us. We can test the samples after the calibration. E27 fixture is for bulbs. The big cross fixture is for other luminaires. The G-axis can be rotated to 45 degree for installing the sample. Turn on the cross laser and make sure that the cross laser points to the marker on the opposite wall. Pull the bolt first to get the fixture stuck and then tighten the screw to ensure that the fixture will not fall out at any time. It is necessary to install the luminous surface of the sample in the center of the cross fixture. After the sample is installed, the height of the sample is adjusted by the lifting switch on the side of the light arm to make the luminous surface of the sample at the same height as the horizontal laser. If it is a bulb lamp, adjust the bulb to make the middle of the bulb at the same height as the horizontal laser. Plug the sample power cord into any of the red and black terminals of the light arm. According to the sample, switch the AC/DC switch to the correct position. We can control the output of AC power supply and DC power supply on the software directly. Enter the software system configuration. For the power meter, select the power meter model if it is an AC sample. Select the same DC series power supply as the power meter if it is a DC sample. Select the FAR detector. Click Test. The first step, fill in the sample specification parameters. It can also be filled out after the test. Click Next. The second step, select and confirm test parameters. C-plane is for the sample's rotation angle. If no special requirements, please always choose no symmetry. No need to change the rotation range, 0 to 180 degrees. The interval option is from 0.1 to 90 degrees. Here are the principles of choosing the interval. If the sample is symmetrical and uniform light, you can choose a bigger interval such as 30, 45. Otherwise you need to choose a smaller interval, such as 10, 15. Bigger intervals need less time to do the test. Small intervals need longer time but the data is more accurate. G-plane is for the mirror's angle. There are two options for the rotation angle range of the G-plane. -90 degrees to 90 degrees is for samples with exposure angle less than 180 degrees, such as down lights, panel lights, etc. -180 degrees to 180 degrees is for samples with exposure angle greater than 180 degrees, such as various bulb lights. Although some luminaires' exposure angle is less than 180 degrees, but it is also need to test the backlight according to the standard. Then you need to choose -180 to 180 degrees. If there is no special requirement for G angle interval, just choose 1 degree. There are 3 test speeds available: high speed, normal speed, and low speed. If you test samples with a narrow beam angle, you need to set 0.5 or less angle interval for G-plane. And then you need to choose low speed to do the test. In addition, you can choose the default normal speed for testing. High speed is not recommended for frequent use. The software has 2 preheating options. Enter preheating time directly, or automatic monitoring of light intensity stability. If both are checked, the software will test automatically after both conditions are met. There are 2 options for the stop positions of G-axis after the test. The second option is checked by default, so that after the test, it is convenient to directly remove the sample and install other sample. The software will automatically save the test results. Just select the folder path. Enter the file name you want to save. Check Add suffix automatically to avoid overwriting the test results file if you forget to change the file name. Click Next. If you want to know the illumination and intensity values, you can click Sample. If the power meter communicates normally, the electric parameters will be displayed here automatically. During the test, the darkroom should be closed and there should be no stray light inside. Click Start to start the test. If the preheating option is checked, the test will start after the preheating is over. For near-field detector measurement, cover the mirror. Install and turn on the sample in the same way. Enter the software system configuration and select the near detector. The next steps are the same as the far detector test. The spectroradiometer is located at the near detector. Install and turn on the sample in the same way. Cover the mirror. Go to the software system configuration and select the spectroradiometer. When testing the color distribution, the spectroradiometer requires integration time. So the test speed is slower than the photometric test. We can also choose a big interval for G-axis just like the C-axis interval. The remaining steps are the same as far detector and near detector tests. After the test, you can check the test results on the software. The test procedure is C-gamma test. Some kinds of luminaires such as floodlight need to be tested by B-beta. LSG software can convert the C-gamma report to B-beta report. You can also export IES, LDT, or files in other formats. You can print the report as PDF or on papers. Check and confirm the print options. Click Preview to preview the report and click Print to print the report. The G-axis and far detector will rotate continuously during the test. Do not place anything within the rotation area. In the far field test, the light of sample is reflected to the far field detector by the mirror. Keep the mirror clean and tidy. We will update the software to meet the latest standards and add new functions. We will send you the new software in time and guide you to update. Thanks for watching.